So we're on addition and subtraction of matrices. To add or subtract matrices, the matrices must be of the same order. That is, they must have the same row and column. So example, and when adding, you add correspondingly. So if you have a matrix A, maybe 2, 3, 5, 8, 9, 10. So this 2 by 3 matrix. So for you to add any other matrix to it, they must have the same row and column. So if you have this one, maybe 8, 8, 1, 5 minus 4, 2, 8. So this is also 2 by 3. So we can add or subtract. And while adding, we'll add or subtract correspondingly. So if you are to find A plus B, the result must be 2 by 3 again. So 2, first element here adds to that. So 2 plus 8 is 10. 3 plus 1 is 4. 5 plus 5 is 10. 8 plus minus 4 is 4. 9 plus 2 is 11. While 10 plus 8 is 18. So that's it. Or maybe if you are asked to do B minus A. So let's see. 8 minus 2 is 6. 1 minus 3 is minus 2. 5 minus 5 is 0. Minus 4 minus 8 is minus 12. 2 minus 9 is minus 7. And 8 minus 10 is minus 2. So have you seen it? So whenever you are to add or subtract matrix, you add correspondingly. First row to first row, first column to first row, first column. So that's it. So let's do multiplication. Multiplication of matrix. To multiply two matrices, that's if it's possible, because not all multiplication is possible. So if you are to multiply, you have to check the column of the first matrix to know whether it is equal to the row of the second matrix. That's the statement. The column of the first matrix must be equal to the row of the second matrix. And while multiplying, you multiply row by column. I will explain. So, but first thing, if you're assuming you are given M by N matrix to multiply by maybe any other matrix, for the multiplication to be possible, the column here must be the same thing as the row here. So this makes it possible for us to multiply. So this is possible. It's possible. So assuming maybe if the row is P. So you see that the column here, once is equal to the row here, the multiplication is possible. And the result, that's after multiplication, the final matrix that will be formed will be M by P. So this is just the resultant matrix. So the matrix must be equal, the row of the matrix must be the row of the first one and the column of the second one. So that's the trick. So let's now do the proper multiplication. So assuming you are given, so we're given this example and we're asked to find the product. We are given this one and this, find that. So I told you the first thing you have to check whether the multiplication is possible. So I'm starting with the first matrix. The first question. So this is 1 by 3 matrix. Why this is 3 by 1, 3 rows and 1 column. So do you see it's 3, 3? So it's possible, and the matrix that will be formed is 1 by 1. So I told you multiply row by column. So this row will multiply the column. So we see that AB is now a bigger matrix. 3 times 7 So this to this to that, that to that. Do you get? So row by column. And after you add all the three, so we have plus 4 times 5 plus 5 times 6. So that's it. No more, because assuming they will have another row, the same row will multiply the column. So each row will multiply all the columns. That's it. We don't have any more rows, so we'll stop. So our answer is 3 times this is 21 plus 20 plus 30. So this is 71. So this is our matrix, which is 1 by 1. First row, first column, 1, 1. So that's our answer. So coming to the second one, this the first matrix is 2 by 3. While the second matrix is 3 by 1. So you can see 2 rows, 3 columns. 3 rows, 1 column. So this is possible. So the answer, the final matrix will be 2 by 1. So let's multiply to get 2 by 1. So we are multiplying. This is PQ. Okay, solution. So PQ is now, remember, we'll multiply row by column. So we'll start 2 times 7. You add it to 1 times 5 plus 3 times 6 we are done. So the first row have succeeded multiplying the column, and we have only 1 column. If there is another column, we still multiply. So we'll go over the second row. So the second row will do the same and multiply. So we have 7 times 7 plus 5 times 5, 5 times 5, and finally 4 times 6. As you can see, the matrix that is formed is 2 by 1. Yes, 2 by 1. Because this is 14 plus 5 plus 18. Why this is 49 plus 25 plus 24. So which this 19 plus 18 is 37. So 37. Why this is 49. 49 plus 49 is 98. So do you see we have 2 by 1 matrix, 2 rows and 1 column. So the next one, the final one. So this is the last one. So we have AB, but now will be little more. I won't waste time. I will be fast because we've done a lot. We've done 2 already. So, and this has a larger number. This is 3 by 3. Why this is also 3 by 3. So we now do more work. So we start with 4. So remember, first row we'll multiply first column. After that same first row, we'll multiply the second column. After the first row again, we'll multiply the third column. After we have done with the first row, we'll go over to second row, multiply each, multiply the third. So that's how we do it. So let's go. We start 4 times 1 is 4. So 4 plus 1 times 8 is 8 plus minus 3 times 1 is minus 3. So this now becomes the first element here. So again, we start 4 times minus 2 is minus 8. 1 times 5 is 5. Minus 3 times 3 is minus 9. So we are done. So to the third column, 4 times 2 is 8. Plus 1 times 6 is 6. Plus minus 3 times 1 is minus 3. So we are done with so this just gives us the element of the first row. So let's move to the second row. So the second row multiplies the columns. So we start 1 times 1 plus 5 times 8 is 40, plus minus 3 times 1 is minus 3. So we are done with the first element. So the second one, we'll go to the second row. 1 times minus 2 is minus 2. 5 times 5 is 25. Minus 3 times 3 is minus 9. So we are done. So we'll move to the third column. 1 times 2 is 2. 5 times 6 is 30. Minus 3 times 1 is minus 3. So we are done with this second row. We'll move to the third row. 2 times 1 is 2. Okay. So 2 times 1 is 2. 7 times 8 is 56. Plus 0 times 1 is 0. So we are done. We'll move to the second column. 2 times minus 2 is minus 4. 7 times 5 is 35. 0 times 3 is 0. So final column. So 2 times 2 is 4. 7 times 6 is 42. 0 times 1 is 0. So we have that. Let's add now. This is 12. 12 minus 3 is 9. Minus 8 plus 5 is minus 3. Minus 3 plus minus 9 is minus 12. 8 plus 6, 14. 14 minus 3 is 11. So we are done with the first row. So we'll move to the second row. 1 plus 40 is, or maybe 40 minus 3 is 37 plus 1. 38. 25 minus 2 is 23. 23 minus 9 is 14. And so 2 plus 30, or maybe 30 minus 3, 27 plus 2, 29. So move to the last row. 2 plus 56 is 58. 35 minus 4 is 31. Y 4 plus 42 is 46. So this is our matrix. So let's go over to determinant.